This is number 26 from 7.3, another combinations style problem. Here's the original equations. You write them over each other, stack them like that so you can work on canceling out terms. Right now the B term and the C term don't line up, so we actually need to switch places with these to get them to line up. So 5C plus B, 5C and a plus B, which we don't necessarily need to write the plus sign out front. Now, if we add these together, we won't get rid of the B or the C term. So what we need to do is multiply the whole thing times something that will cause these numbers to change such that they'll cancel out. So I'm picking -3 because I know that -3 times 1 is going to cancel out with that +3. I don't really care what happens to these, but I will be careful and multiply them correctly. But this is really my target. The logic of these combinations is we've got to get this to cancel out. So you pick something to distribute in, and you have to ask yourself if that's, okay, like if that's legal, does that obey logic? And the logic is, if this side of the equation is equal to that side, as long as you treat this side the same way you treat that side, then it's okay. So that's why it's okay to multiply 3. We're going to distribute to every term. This whole side is going to be tripled negatively, and so is this side going to be tripled negatively. So the effect is that both sides of the equation will be treated the same. So what we end up with, let me see, I'm going to write it all again just to keep it straight here. The top one can stay like that. The bottom is going to be a -3b minus 15c and then -33 over here. So that takes care of distributing it in, and now we're ready to cancel these. +3b and -3b cancel. They essentially make 0b, which 0 times b, it can just be ignored because 0b, we're adding it to whatever this is, and 0 plus whatever it is, this term can be ignored. So this would be a -13c, and here we'd have, gosh, what's that, 13? Is that right? Yes. So divide by -13, and c is going to equal positive and a negative, make a -1. Now we just plug that back into our choice of equations. I'm going to pick the original before we tripled it. So I just plugged that -1 in for c, because that's what it equals, and rewrote it. There's the c. So b plus, minus 5, because plus 5 times a -1, these two are going to make a -5 equals 11. So if I add 5 to both sides, I will find out what b is equal to. b equals 16. So if I put them in alphabetical order, b, c, we would have 16, -1. And if we plug those 2 points into each of these equations, it should spit out a true statement to prove to us that we got the right point of intersection. And there's a good example of combinations where you have to do some clever thinking to get these to cancel out.